Good evening, all the GW soldiers. How is everyone doing? Welcome to Gate Wallah English channel, which is dedicated to all the students who want to prepare for Gate through English medium. And this is revision through question series for all the Gate 2023 aspirants. And today we are going to revise engineering mechanics. And let me tell you, this is a very high weighted subject, engineering mechanics, for mechanical as well as XE. So if you are preparing for GATE ME or GATE XE, today we are going to revise engineering mechanics, all chapters of engineering mechanics, including Lagrange's equation. So how is everyone doing? Welcome everyone. Hope all of you are preparing really well. So let me tell you that we started this series revision through questions so that we can revise the entire syllabus of mechanical engineering through questions. There is no better way to revise your concepts, to revise your chapters, rather than through questions. If you solve questions, you will get to know where you are stuck, which concepts are very clear to you, you don't need to revise them, which lectures you need to follow again, you need to see again. Okay, so beta, we started this series on 12th of January. The first lecture was taken by Negi sir of basic thermodynamics. Today I am taking engineering mechanics, and don't forget that tomorrow you have two subjects, you have two lectures of revision through questions. One is mathematics by Vishal sir, and the timing is 2 p.m. to 4 p.m. Okay, so tomorrow you have two lectures, mathematics 2 p.m. to 4 p.m. and then at 4 p.m. you have material science and manufacturing processes by Swadesh sir. Okay, so beta, note this down. Don't forget to tune in to log into both of these lectures. Very important lectures by two legendary teachers of Team Drona. Okay, and then after that you have this entire schedule. Note this down and don't forget to watch all these lectures live. We have dedicated this entire series for all our students who are comfortable in English. Good evening, very warm welcome to everyone. So beta, Team Drona is there for each and every student, whether you are comfortable in Hindi, whether you are comfortable in English. We have dedicated YouTube channels for both of these students, and we are providing endless number of quality series, quality lectures to all of you. Okay, so beta, let's start the first question of today without wasting any time. And let me tell you beta, I have all types of questions, NAT questions, MCQ questions, MSQ questions, and all these questions are designed and curated personally by me. So I have designed very beautiful questions to for all of you, and let me tell you, all these questions are completely new. Okay, so this is the first question, and it is an NAT question of 1 mark. Okay, so we will start with simple questions and then slowly we will increase the difficulty level. Okay, so first question is, a wooden block weighing 50 Newton is placed on a horizontal plane. A horizontal force of 10 Newton is applied and the block is ready to move. Means it is on the verge of motion. Angle of friction is, I hope that you guys remember what is angle of friction. Phi, which is equal to 10 inverse of mu, right? So you need to first find out mu, and then you need to find out the 10 inverse of mu, which will give you the angle of friction. Okay, so first draw the free body diagram of this block. It is 50 Newton of weight. The weight of this block is 50 Newton. Okay, and it is subjected to a force of 10 Newton and it is on the verge of motion. Okay, so this is 50 Newton. This is 10 Newton. Now, it will have a normal force from here. Let me call this N1. And there will be a friction force as it is on the verge of motion. What will be the friction force? As it is on the verge of motion, friction force will be mu N1, right? Now, It is on the verge of motion. It is not actually moving. So statics equilibrium equations are valid here. So apply the equilibrium equations. What are you going to get? From summation of fx equals to 0, mu n1 is equal to 10 Newton, and from summation of fy equal to 0, n1 is equal to 50 Newton. So we are getting the values of n1 and mu n1, right? So if I take the ratio of these two, what I am going to get? Equation 1 divided by equation 2 will give me the value of mu, which will be 0.2, right? Mu is 0.2. So angle of friction, which is usually denoted by phi, will be 10 inverse of mu. So what is 10 inverse of 0.2? What all of you are getting? 10 inverse of 0.2. It is 11.3099. Let me round it off. So it will be 11.31 degree, almost 11.31 degree. Yes. So everyone is getting 11.31 degree. So the answer to this question is almost 11.31. First question, 1 mark question, but it was a conceptual question. So shall we move on to the next question? Are you guys ready for more questions? Chalo. So let's move on to the next question of the evening, and this is an MSQ question of 2 marks. MSQ question of 2 marks. Okay. MSQ means there are multiple answers possible to this question. Member ABC of negligible weight is supported by a pin at A and a bracket at B, and an inextensible cord attached at A and C passing over a frictionless pulley at D. For the loading shown and neglecting the size of the pulley, which one or more of the following statements is or are correct? Thank you so much, buddy. Thank you so much for the compliment. So we have these 4 statements. Tension in the cord is 75 Newton, tension in the cord is 300 Newton, horizontal reaction at the pin B is 300 Newton, vertical reaction at the pin B is 225 Newton. So basically we need to find the tension in this cord and the horizontal and vertical reaction at the pin. So what you need to do is draw the free body diagram of this L-shape frame. Draw the free body diagram of this L-shape frame. Draw the free body diagram of this L-shape frame quickly. So the base, this is 160 mm and this is 250 mm. Okay. Now what are the different points here? A, B, C. Okay. So this is A, this is C, and somewhere here is a pin at B. Right? 120 mm means almost at half. Now, what are the different forces acting on it? There is a 75 Newton force acting at A, vertically downwards. Now, there is a cord attached at A and C. So there will be tension in that cord, and as it is passing over a frictionless pulley, tension on both sides will be same. This is a frictionless pulley, so tension here and here are going to be same. Now there is a pin support at B, hinge support at B. So you are going to get two reactions at B, right? One in X direction, one in Y direction. I don't know the direction of those reactions. So I am going to assume any particular direction. Let me call this BX, okay? And let me call this BY. These are the reactions in X and Y direction at point B. Now, how many unknowns do you see here? Bx, by and t. We have three unknowns and we have three equilibrium equations. Okay. So first we are going to find the tension T in the cord by taking moment at point B. If we take moment at point B, moment of Bx and By will become 0. So you will get the magnitude of tension T, right? Now, the moment of this tension is going to be clockwise, right? So it will be T multiplied by, what is this distance? This distance is 160 mm. This distance is 160 mm. This is 120 and this distance will become 130. Okay. So T multiplied by 160. Okay. Clockwise. Moment of this T is anti-clockwise. So minus T into 120. And moment of this 75 Newton will also be anti-clockwise. 75 into 160 equals to 0. So what is the tension in the cord? It will be 75 into 160 divided by 40 means 300 Newton. I am getting tension in the cord 300 Newton. Is everyone getting the tension 300 Newton? Very good, excellent everyone. So the tension in the cord is 300 Newton, right? So this statement is correct. This first statement is wrong. Now horizontal reaction at B is 300 Newton. So if I apply summation of Fx equals to 0, there are two forces in X direction, Bx and this T. So Bx will be equal to T, which is 300 Newton. Okay. So the horizontal reaction at pin B is 300 Newton. So this statement is also absolutely correct. Yes. Very good. Now the net force in Y direction equal to 0. So in Y direction we have three forces, By plus this T, which is 300 minus this 75. So By is equal to 225 Newton. The reaction at B in Y direction is 225 Newton. So this statement is also absolutely correct. So we have three correct statements, B, C and D. Everyone is getting this answer? Very good everyone, very good. So this was an MSQ question for 2 marks. I hope you guys liked this question. So the concepts of static and the most importantly the equilibrium equations are clear, right? So shall we move on to the next question then? Shall we move on to the next question? Let's move on to the next question, and this next question is another MSQ question of 1 mark. So I have lots and lots of MSQ questions for you guys. So let's read the question. A particle starting at t equals to 0 moves in a straight line with equation of motion given by s equals to t plus 2t square, where s is in meter and t is in seconds. Which one or more of the following statements is or are true? Again, an MSQ question, more than one possible answers are there. So basically we have the equation of displacement with respect to time. Okay, and they are saying, is the initial velocity 1 meter per second? Is the initial acceleration 2 meter per second square? Particle moves with constant velocity or particle moves with constant acceleration? Which of these statements are correct statements? So we have the equation of S equals to t plus 2t square. So how do we get the velocity and acceleration from here? You guys remember, right? V is equal to instantaneous velocity. V is equal to ds by dt. So this will become 1 plus 4t, right? And then instantaneous acceleration A is given by A equals to dv by dt. So it is going to be 4, right? So this is the equation of velocity and this is the equation of acceleration, right? Now the first statement is initial velocity is 1 meter per second. Initial velocity means at t equals to 0. That was the initial time. So at t equals to 0, v will be 1 meter per second. So this is absolutely correct statement, right? This is absolutely correct statement. At t equals to 0, initial velocity is 1 meter per second. Initial acceleration is 2 meter per second square. Now what will be the value of A? A will remain 4 meter per second square only, right? So this statement is wrong. Particle moves with constant velocity. Now does the particle move with constant velocity? Does the particle move with constant... I'm really sorry. Does the particle move with constant velocity? No, because we have acceleration, right? So the particle will not move with constant velocity. At different values of time, we are going to get different velocities. So it does not move with constant velocity. But does the particle move with constant acceleration? Yes, the particle moves with constant acceleration. Why? Because A does not depend upon time. A is not the function of time. It is independent of time. So it doesn't matter what time is there, t equals to 0, t equals to 1, t equals to 2, t equals to 3, A will remain constant, 4 meter per second square. So the second answer is D, particle moves with constant acceleration. So only two statements are correct, A and D. Initial velocity is 1 meter per second. Particle moves with constant acceleration. So I hope that all of you got the correct answer to this. It was a 1 mark question, a very simple question, right? So shall we move ahead? Shall we move on to the next question? Are you guys thrilled to solve more questions? Chalo, chalo, chalo. So this is just the beginning of this. We have lots and lots more of questions. Let's move on to the next question. And this is an NAT question and it is of 2 marks. Due to slipping, points A and B on the rim of the disc of radius 2 meter have the velocities as shown in figure. So we have a disc which is slipping on a horizontal surface, and as there is slipping, there is velocity at point of contact. Usually we get questions of rolling without slipping. So at point of contact the velocity is 0. But in this particular question we have slipping. So there is velocity at point of contact and that velocity is mentioned. VA is 5 meter per second, VB is 10 meter per second. magnitude of velocity at the center C of the disk is. So let's solve this question. Now, how are we going to solve this question? In order to solve this question, we have to approach. We can either use the relative velocity method or we can use the eye center method. Okay, so which method are you guys using? I want to know which methods do you prefer? Relative velocity method or the eye center method? Eye center method? Chalo. So let's solve this question by eye center method. Now, in order to solve this question by eye center method, we need to locate the eye center. Okay. So how are we going to locate the eye center? We have the magnitude and the direction of velocities at A and B. Okay. So let's first connect the points A and B. These are the points A and B. This is B and this is A. Okay. Now, the velocity at A is 5 meter per second and the velocity at B is 10 meter per second. Okay. So, I will draw a line showing the velocity of B and then a line showing the velocity of A. So, this is 10 and this is 5. Now, if I connect the ends of both these, then the point of intersection of these two dotted lines, one joining A and B and one joining these two arrows, this is going to give me the eye center. So I have the location of eye center, but we need to find these distances, right? So let's find out the distance of this eye center from any one point. Let's consider this y. So what will be this distance? What will be this distance? If this is y, this will be diameter minus y. Na? This entire distance is equal to diameter. Diameter is what? 4 meter. So this is going to be 4 minus y. Don't make the mistake of writing it 2 minus y. Okay, it is going to be 4 minus y. Now, from similar triangle, we can write y by 5 equals to 4 minus y by 10. So it will become 10y equal to 20 minus 5y. So 15y equals to 20. So y will be equals to what? 20 by 15, 1.33 meters. So we have got the location of the eye center. Now we need to find the magnitude of velocity of center C, right? We need to find the magnitude of velocity of center C. So where is the center C? Center C is going to be here. Okay. What is going to be the distance of center C from eye center? What is going to be that distance from center C to eye center? Well, this is 4 minus y and this is 2 meter. So 4 minus y minus 2. 4 minus 1.33 minus 2. So this distance is 0.67. Right? This is 1.33 and this is 0.67. Okay. So what will be the velocity of C? What will be the velocity of C? Velocity of C will be this. Okay. So how we are going to find the velocity of C? Again we can apply the similar triangle. Na? velocity of C divided by 0.67 equals to 5 divided by 1.33. So velocity of C is going to be how much? 5 into 0.67 by 1.33. So it is 2.518 meter per second. Is everyone getting this? 2.518 meter per second. 2.518 meter per second. Around 2.5 meter per second, right? We can round it off to 2.5. Yes? Everyone got the answer? Very good, yeah, very good, very good. Excellent, everyone. Very good. Chalo. Yes. 2.5 meter per second. Let's write it. Otherwise, people will get offended. Nowadays, people get offended very easily. Chalo. So let's move on to the next question. Shall we move on to the next question? Chaliye, chaliye. Now, this is a very interesting question. Let's see how many of you get the correct answer to this. An MCQ question, and it is of 1 mark only, okay? You don't need to solve anything. It's a conceptual question. A circular table rotates about a vertical axis with a constant angular speed, okay? A circular pan rests on the turntable with the center coinciding with the center of the table and rotates with the table. Okay, so we have a pan, you can see, which is resting on this turntable. Bottom of the pan is covered with uniform thick layer of ice, which also rotates with the pan. So you can see that there is ice inside this entire pan. Okay, the ice starts melting, angular speed of the turntable. Once the ice starts melting, this pan is filled with ice. Okay, the bottom surface of the pan is completely covered with ice. Okay, and it is a thick layer. So now when this ice starts melting, what is going to happen to the speed of the turntable? Is it going to remain same? Is it going to decrease? Is it going to increase? Or is it going to depend upon the thickness of the ice? What is it going to be? Okay, some people are saying it's going to increase, some people are saying it's going to decrease, and some people are also saying that it is going to remain same. Is there anyone who is going to go with the answer D? So if I was in KBC and if I would have taken the people poll option, then I would have lost the game, right? Because different people are giving different answers. Okay. Yes, you are right. We are going to apply conservation of momentum. What does conservation of momentum says? See, it is rotating. So we are going to conserve the angular momentum. And what is angular momentum? What is angular momentum? Angular momentum is given by I omega, right? Angular momentum is given by I omega. where I is what? I is mass moment of inertia. Now beta, tell me what is mass moment of inertia. Can anyone explain in simple words what is mass moment of inertia? I don't need a technical answer. I don't need a bookish definition. I need just in simple words, in layman language, what is moment of inertia? So basically, moment of inertia is the distribution of mass from a particular axis. How far the mass is distributed from an axis, right? If the mass is closer to the axis, moment of inertia is less. If the mass is away from the axis, moment of inertia is more. Now understand this. First of all, you need to get this, that the ice is going to melt into water, but that water is going to remain inside the pan, right? So some people are saying that when the ice is going to melt, the mass is going to reduce. No. First of all, don't focus on the mass, focus on the mass moment of inertia. Second, it is not going to reduce because of the melting of the ice. See, once the ice is going to melt, it will be converted into water, but it will still remain in the pan, right? That water is going to remain in the pan. Now, look at the pan right now. Look at the pan right now. If I look at the pan right now, let's say this is the pan. If this is the pan, then the ice is everywhere, right? This is ice, right? But once this ice is going to become water, then what is going to happen? Can anyone tell me? Once the ice is going to be converted into water, what is going to happen? That water will not be uniformly distributed, right? As this is rotating, the water, due to which force? Centrifugal force, is going to go to the corners. That water will be in the corners like this. Why? Water is accumulated in the corners. Why? Because of centrifugal force, right? Water gets to the edge of pan because of centrifugal force. I'm so sorry. Because of centrifugal force. As the centrifugal force is acting outwards, due to that the water is going to accumulate on the edge of the pan, right? When it is ice, it is uniformly distributed, but when it becomes water, it is going to go here. Now the mass will remain same, right? But the mass moment of inertia, what will happen to mass moment of inertia? Let's say the mass moment of inertia of this is I1 and mass moment of inertia of this is I2. So beta, what is the relation between I1 and I2? Can anyone tell me? See, the mass is going away from the axis, right? This is the axis of rotation. So mass is going away from the axis, and if mass goes away from the axis, the moment of inertia is going to increase. So beta, I2 will be greater than I1. I2 will be greater than I1. Now from the principle of conservation of momentum, see, the force, the net torque is constant, right? So the momentum is conserved. So I can write I2 omega 2 equals to I1 omega 1. Okay. So I can write omega 2 equals to I1 by I2 omega 1. Now beta, I2 is greater than I1. or I1 is less than I2. So this value is less than 1. So you can say that omega 2 is less than omega 1. Are simple words mein you can say that omega is inversely proportional to I. So if I is increasing, omega is decreasing, right? So do you understand the solution here? It's not exactly the solution, it's the explanation. Do you understand the explanation here? When the ice melts into water, due to centrifugal force, water gets accumulated to the edge of the pan. Okay, so it will increase the mass moment of inertia, and if mass moment of inertia increases, omega decreases. As the momentum will be conserved, I into omega will remain constant. So if I increases, omega reduces. So how was this question? How was this question? See, it is not a very difficult question. It's just that you need to focus on your basics. Okay, don't forget about the basics. Okay, so you need to closely observe what is happening. Problems of engineering mechanics are very much related to the practical life. You can imagine this situation in your head. So whenever you have a conceptual question of engineering mechanics, what you need to do is imagine this situation in your head. What is happening? And then try to understand how you can apply your concepts to this problem. Okay? Okay. So let's move on to the next question. Why it will not spill out? Because see, there is no mention of it is spilling out. Okay, if it spills out, then beta you need to exactly know how much water is going to spill out, right? So if you rotate this at a very high speed, yes, it will start spilling out. But yes, there is no mention of it spilling out. We are going to assume that right now the entire water is inside the pan only. Okay, so you have to take that liberty of assumption that the water is not spilling out. Okay, chalo, let's move on to the next question. And this next question is another MCQ of 1 mark, and let me tell you, it is another conceptual question. Okay, two boxes of mass 5 kg and 10 kg are released from rest from a frictionless inclined plane. When the boxes reach the bottom of the inclined plane, ratio of their kinetic energies is. Solve this problem. This is another conceptual question. Okay, two boxes of mass 5 kg and 10 kg are released from rest from a frictionless inclined plane. When the boxes reach the bottom, what will be the ratio of their kinetic energies? So let's say this is that inclined plane. Okay, and let's say this is our box. Okay, now what is happening is we are releasing this from the inclined plane from rest. Initial velocity is 0. Now when it will reach to the bottom, let's say velocity is v. Okay, now what is happening here? Understand it. What is happening here? Understand it. Okay, I'm so sorry, there are two same options here, so let me change this. Okay, so now we have 4 different options. Okay, so what is happening here? Understand it. Let's say this is the center of gravity. Okay, and let's say it is at a height h. As it is a frictionless plane, no loss of energy. So can we apply conservation of energy? as it is a frictionless plane, no loss of energy. So we can apply conservation of energy, means kinetic energy at the bottom will be equal to potential energy. See, right now it has potential energy equal to mgh. When it will be released, the potential energy will decrease and kinetic energy will increase. As there is no loss of energy, I can say that the entire potential energy will be converted into kinetic energy. So can I say kinetic energy will be equal to mgh? Now the g and h are same for both, right? The g and h will be same for both. They are released from the same point. The only difference is m. So I can say that kinetic energy for both the boxes will be proportional to their masses, m, right? G and h for both the boxes are same. They are released from same height. The g will be same, but the mass is different. So I can say that kinetic energy of box 1 by kinetic energy of box 2 equal to m1 by m2, which is 5 by 10. So kinetic energy of box 1 by kinetic energy of box 2 is 1:2. Yes, the answer is 1:2. Now here, let's say that I introduce friction. Let's say that I introduce friction here. Will the answer remain same? Can anyone tell me, will the answer remain same? If I introduce friction here, if I say that the coefficient of friction, kinetic friction is, let's say, 0.2, will the answer remain same? Will it remain same? If I introduce friction here, if mu between the surfaces, kinetic coefficient of friction between the surfaces is 0.2, will the answer remain same? No. Yes, the answer will not remain same. The answer will not be same, because in that case you will not be able to apply the conservation of energy, because some energy will be lost in friction, due to friction, right? So in that case, how you are going to solve the problem? Can anyone tell me, if I introduce friction, how you are going to solve the problem? Very good, excellent, excellent. Yes, very good, Sumant. You are going to apply the work energy method. Let me tell you this. Conservation of energy and work energy, they are not exactly same. Conservation of energy is only valid when there is no loss of energy, but work energy can be applied even if there is loss of energy due to friction, right? Even if there is loss of energy due to friction, we can still apply work energy method. So what we are going to do is, instead of equating the kinetic energy with potential energy, we are going to equate kinetic energy with work done. Okay. Now we are going to find the net work done. How we are going to find the net work done? It will be equal to the net force acting in the direction of motion multiplied by the displacement. Now this displacement is going to be same for both, but net force in the direction of motion will be different. So it will be the ratio of net force, not the mass. It will become the ratio of net force, not the mass, right? Is it clear? Is it clear? Chalo. So let's move on to the next question. Okay, let's move on to the next question. Now, I am not saying that the answer is going to change in every case. Maybe in that case also the answer can be same. If the net force in the direction of motion is also in the ratio 1:2, you are going to get the same answer. Okay, but you need to check. That's all I am saying. Your answer can be same or your answer can be different. Okay, but your approach is going to be different. In that case, it will not be equal to potential energy, it will be equal to work done. So you will find the ratio of work done, force into displacement. Displacement will be same, so it will be the ratio of net force. Now let's solve this brilliant question of 2 marks. It is an NAT question. I'm so sorry. It is an NAT question. Okay, it is an NAT question of 2 marks and it is a very good question. Okay, let's focus on this and let's solve this. The static coefficient of friction between the 10 kg crate and the 30 kg cart is 0.2. Static coefficient of friction between the 10 kg crate and the 30 kg cart is 0.2. Assuming there is negligible friction between wheels of cart and the surface. There is friction but negligible. Neglect that friction. The maximum force P that may be applied to the crate without causing it to slip on the cart is. The maximum force P that may be applied to the crate without causing it to slip on the cart is. So understand what is happening here. There is a 10 kg cart which is placed on a 30 kg, 10 kg crate which is placed on a 30 kg cart. The cart has negligible friction, okay. There will be friction, otherwise it will not rotate, it will just slip. But you neglect that friction. Now we are applying a force P here and it is said that without causing slip of this crate with respect to the cart, means you should not have relative motion between crate and cart. What can be the maximum force P here? What can be the maximum force P here? Now understand the situation here, okay. As there is negligible friction between the wheels and the surface, if I apply a horizontal force here, will it remain static? Will this entire system remain static or will it start moving? Because first of all, you need to understand whether it is a question of statics or kinetics. It's a very common mistake that sometimes students solve problems of statics as problems of kinetics and problems of kinetics as problems of statics. So first of all, tell me whether it will remain static or whether it will move. Yes, of course it is going to move because there is no opposing force, right? There is no opposing force. So of course it will start moving, right? So it is a problem of kinetics, not statics. Is that clear to everyone? Is that clear to everyone? It is not a problem of statics, it is a problem of kinetics. So let's assume that this 10 kg crate and 30 kg cart both are moving. Now they are saying that there should be no slip between this crate and the cart. So can I say that both are moving with same velocity, same acceleration? Can I say that? Both are moving with same acceleration, same velocity. Can I say that? Because there should be no slip between both the bodies. So they are moving with same acceleration. Now let's solve this problem. So we have this cart. On top of the cart, we have this crate. Okay. These are the wheels of the cart. Now understand. Right now I am considering both the bodies together. Okay. We are applying a force P here. We are applying a force P here. Weight of the crate is 100 Newton. Weight of the cart is 300 Newton. There will be some reactions from here and here. Okay. Now, both the bodies are moving with the same acceleration. Both the bodies are moving with the same acceleration. So right now, let's consider both the bodies to be a single body moving with acceleration A. So from Newton's second law, can I say summation of F equal to ma? Can I say that from Newton's second law? Can I say that? Yes, I can say that. What is the net force in the direction of motion? Right now we are considering both the bodies together. So what is the net force in the direction of motion? The net force in the direction of motion is P. We are not considering the friction force on the wheels. They are saying negligible friction between wheels and surface. So we are not considering friction force acting on wheels. So P will be equal to M. Now we are considering this entire system as a single body. 10 kg plus 30 kg. Total mass will be 40 kg. Na? So can I say A is equal to P by 40? Now why I wanted this equation? Because when I draw the FBD of this 10 kg crate, I will need a relation between A and P. Then only I will be able to find P. You will understand when we will draw the free body diagram. Now consider the crate alone. Isolate the crate. Consider the crate alone. Draw the free body diagram of the crate. Draw the free body diagram of the crate. So the crate is subjected to a force P. The weight of the crate is 100 Newton. Now assume that the crate is just about to slip. It is not actually slipping. It is just about to slip. So in that case, the friction force between the crate and the cart will be maximum. And it is going to be the static friction force. Okay, it is going to be the static friction force. Okay, the static friction force is 0.2. We are assuming that the crate is just about to slip. It is not actually slipping. It is moving with cart. It is just about to slip, on the verge of slipping. So the friction force between crate and cart will be mu s into N1. Okay. Now, from summation of Fy equal to 0. See, in this direction it is not moving. Na? It is moving in this direction. In this direction it is static. So I can say N1 equals to 100 Newton. Now, if I apply Newton's second law here, I will get this. I will get this. This is moving with acceleration A. Still moving with acceleration A. What is the net force in the x direction? P minus mu s n1. And it will be equal to ma. What is m? 10 kg into A. Now put all the values here. So it will become 0.2 into 100 equals to 10 into P by 40. Now in this equation there is only one unknown, P. So can you give me the value of P? Can you give me the value of P? It is 26.67 Newton, right? The value of P is 26.67 Newton. Yes, very good, excellent everyone. The value of P is 26.67 Newton. Okay. So you can apply maximum of this much force without causing the crate to slip on cart. If you apply more than this, then the crate is going to slip. It was 40 by P or P by 40? P by 40, beta. not 40 by p. तनिक यहां देख लो बेटा, p by 40 था, 40 by p नहीं था. Okay. So let's move on to the next question then. Let's move on to the next question. So how was this question? Excellent. So this was an NAT question of 2 marks. Okay. Let's move on to the next question. And this is an MCQ question of 2 marks. MCQ question of 2 marks. Solve this one. Solve this one. A body was thrown vertically downwards from the top of a tower and transverse a distance of 40 meters during its 4th second of fall. We are dropping a body from the top of a tower which is 40 and it transverses a distance of 40 meters during its 4th second of fall. 4th second, not 4 seconds of fall. 4th second of fall. Find the initial velocity of the body. Assume g equals to 10 meter per second square. So tell me what will be the initial velocity? 2 meter per second, 5 meter per second, 7 meter per second, 9 meter per second. What is the initial velocity? So let's say that this is our tower. Let's say that this is our tower. So a body is falling from this tower with some initial velocity which is unknown to us. Now during its fall, in the 4th second, it travels a distance of 40 meters. Now what is 4th second? Understand this. This is, let's say, t equals to 0. This is t equals to 1. This is, let's say, t equals to 2. This is, let's say, t equals to 3. This is, let's say, t equals to 4. Now this is what? First second. Between 0 to 1, first second. 1 to 2, second second. 2 to 3, third second. And 3 to 4, fourth second, right? This is your 4th second. So during this 4th second, the distance traveled is how much? The distance traveled is how much? 40 meters. Right? Now beta, what is this? What is this? This is the displacement from t equals to 0 to t equals to 3, means displacement in t equals to 3 seconds. And what is this? This is the displacement from t equals to 0 to t equals to 4, means displacement in t equals to 4 seconds. So what is this 40 meters? What is this 40 meters? Can I say this 40 meters is displacement in 4 seconds minus displacement in 3 seconds? Can I say that? Can I say that? Now you might be thinking why we are considering both these distances from 2 equals to 0, because we need initial velocity which will remain same in both cases. So it is going to help in writing the equation. So from t equals to 4 and t equals to 3, these two equations I will get my answer. Now what is the equation of S? It is ut plus half at square, right? Ut plus half at square. So it will be ut plus half at square t equals to 4 second minus ut plus half at square t equals to 3 seconds equals to 40 meters. Now put the values here. The initial velocity u in both cases will be same, and the acceleration a will be equals to g because it is free falling. So the acceleration will be equal to g. So what is the initial velocity that you guys are getting? Everyone is getting 5 meter per second. Everyone is getting 5 meter per second. Everyone is getting 5 meter per second. Let me solve this. Yes. 5 meter per second will be the initial velocity. Very good, very good, very good. So the answer is B, 5 meter per second. So shall we move on to the next question? Okay, let's move on to the next question then. Now this is the question, MSQ question of 2 marks. MSQ question of 2 marks. Solve this one. MSQ question of 2 marks. Solve this one. For the truss shown in figure, neglecting the weight of the members, which one or more of the following statements are true? The truss is a perfect truss. Reaction at E is 3 kilonewton. Force in AB is 12 kilonewton. Force in CD is 6 kilonewton. So it is a simple problem. Okay. We have a truss and we have 4 statements. Which one of these statements is correct? So let's solve one by one. So first of all, is it a perfect truss? Is it a perfect truss? Is this a perfect truss? Is this a perfect truss? Yes, it is a perfect truss. Otherwise, you will not be able to solve this problem. Okay, it is a perfect truss. How many members are there? How many members are there? M is equal to 1, 2, 3, 4, 5, 6. And how many joints are there? A, B, C, D, E. 5 joints are there. So M is equal to 2j minus 3, right? Sorry, 1, 2, 3, 4, 5, 6. 6 members? 3, 4, 5, 6, 7 members, sorry. So M is equal to 2j minus 3, right? So it is a perfect truss, right? It is a perfect truss. Now the next statement is reaction at E is 3 kilonewton. So let's find the reaction at E. So this is a roller support. You are going to get a reaction here like this. And one reaction will be here. So in order to find reaction at E, I am going to take moment at A, right? So if I take moment at A, what am I going to get? Moment of RE will be anti-clockwise. So it is going to be RE multiplied by, what is this distance? Okay, so let's consider this length as L. Let's consider this length as L, and this is also L. Okay, so RE will be RE multiplied by L sine 30. Okay, and it will be anti-clockwise. Moment of this 3 kilonewton will be clockwise, 3 into 2L. So RE is going to be equal to sine 30 is 1 by 2, right? So RE is going to be equal to how much? 12 kilonewton. Are you getting 12 kilonewton? Yes. So the RE is 12 kilonewton. So reaction at E is not 3 kilonewton. This statement is wrong. Okay, B statement is wrong. Now statement C is saying force in AB is 12 kilonewton. So shall we find the force in AB? Force in this member, force in AB. Shall we find? Let's find out the force in AB. So in order to find the force in AB, I am going to take a section like this. Okay, and I will consider the right side part of this truss. So I will get one unknown here, force in AB. I will get one unknown here and one unknown here. I don't want these two unknowns. I want only this force in AB. So what am I going to do? I am going to take moment at point E, right? I am going to take moment at point E. If I take moment at point E, moment of both these two forces is going to be 0, right? Now moment of the horizontal component of FAB will also become 0. I will get the moment of only vertical component of FAB. FAB sine 30, right? So what will be the moment of FAB sine 30? FAB sine 30 multiplied by L minus 3 multiplied by 2L. So what is FAB? Are you getting FAB equals to 12 kilonewton and that too positive? Are you getting FAB equals to 12 kilonewton positive? Means it will be a tensile force, right? So this statement is completely correct, absolutely correct. The force in member AB is 12 kilonewton. Next statement is the force in member CD is 6 kilonewton. Force in member CD is 6 kilonewton. So shall we find the force in member CD also? Shall we find the force in member CD? Let's see whether it is 6 kilonewton or not. So in order to find the force in member CD, I just need to consider joint C. Method of joints I can apply. So here we have 3 kilonewton force, we have FBC, and we have FCD. This is the joint C. This angle is 30 degree. Okay. So I am applying method of joints. Now summation of Fy equal to 0. Net force in the y direction. So it is going to be FCD sine 30 plus 3 equal to 0. So FCD is going to be minus 6 kilonewton, right? Sine 30 means 1 by 2. So FCD is going to be minus 6. Minus 6 means negative sign means I have assumed FCD to be tensile. Negative sign means it is compressive. So force in CD is 6 kilonewton. So this statement is also absolutely correct. So the correct statements are A, C and D. Yes, correct statements are A, C and D. Force in AB is 12 kilonewton tensile and force in CD is 6 kilonewton compressive. So shall we move on to the next question? I hope all of you have solved this one. Shall we move on to the next one? Okay. Moving on to the next question. Now this next question is an MCQ question and of 2 marks. And let me tell you, this is from Lagrange's equation. How many of you have solved problems of Lagrange's equation? Because beta, it is a newly introduced topic. It was introduced for the first time in the syllabus of GATE 2021. And we got one question from Lagrange's equation in GATE 2021. Okay. So a particle of mass m is constrained to move under gravity along a plane rigid wire that has a parabolic shape y equals to x square by L, where x and y are respectively the horizontal and vertical coordinates and L is a constant. The Lagrangian capital L for the system is given by. So let's solve this one. This is from Lagrange's equation. Okay. You don't need to find the entire equation of motion. They are only asking you the Lagrangian. What is Lagrangian? It is kinetic energy minus potential energy. So you need to write the equation of kinetic energy and potential energy for the particle and you will get your Lagrangian. So this particle is moving along a curved parabolic path y equals to x square by L. So it is moving in 2 dimensions. It has velocity in x as well as velocity in y. So we need to find kinetic energy, means we will consider the velocity, total velocity, right? What will be the velocity in x direction? What will be the velocity in x direction? What will be Vx? Vx will be dx by dt, which can be written as x dot, right? Vx will be dx by dt, which will be written as x dot. Now understand, they have written the entire equation in terms of x only. So you have to convert y into x. Can you see that the generalized coordinate here is x? Can you see the entire equation is in terms of x? Generalized coordinate here is x. So we need to write the entire equation in terms of x only. So Vx will be x dot. Now what will be Vy? What will be Vy? Vy will be dy by dt. Now the y can be written in terms of x, x square by L. So beta, what will be Vy? Can I write it 1 by L 2x dx by dt? Can I write it like this, or 2x x dot by L? Can I write it like this? Can I write it like this? How do you differentiate x square in with respect to t? If you differentiate x square with respect to d, you will get 2x dx by dt, and dx by dt is known as x dot. Okay, so I can write it like this. Now beta, v will be equals to root over Vx square plus Vy square na. The velocity V can be written as root over Vx square plus Vy square, or can I say V square equals to Vx square plus Vy square. V square is equals to Vx square plus Vy square. See, the particle has velocity in x direction and y direction. So what will be the net velocity? It will be the resultant of Vx and Vy. So V will be root over Vx square plus Vy square. So V square equals to Vx square plus Vy square. So what will be the kinetic energy, beta? Let's denote kinetic energy with T. So it will be half mv square, means half m Vx square plus Vy square, right? Now put the values here. Put the values here. So what is Vx? It is x dot. And what is Vy? It is 2x x dot by L. So it will become 4x square dot square by L square, right? Right? So if I take half m x dot square common, if I take half m x dot square common, it is going to be 1 plus 4x square by L square, right? This is your equation of kinetic energy. This is your equation of kinetic energy. Half m x dot square 1 plus 4x square by L square. Now we need to also write potential energy. So what will be the potential energy, beta? What will be the potential energy? Potential energy will be mgy, right? Potential energy will be mgy, and y is equal to x square by L. So potential energy will be mg x square by L. See, potential energy is due to the motion in y direction only. Potential energy will be due to the height only, y coordinate only. Due to x coordinate, you will not get potential energy. Potential energy means due to y coordinate, due to height. So mg into y, and y is x square by L, right? So now what is the equation of Lagrangian? Lagrangian L is equal to T minus U. So it will become half mx dot square 1 plus 4x square by L square minus mg x square by L. This is the Lagrangian. This is the Lagrangian. Now which option is matching with our answer? Half mx dot square 1 plus 4x square by L square minus mg x square by L. So this is the correct option. Yes, this is the correct option. Half mx dot square 1 plus 4x square by L square minus mg x square by L. So this was a question from Lagrange's equation. I hope all of you liked this. I hope all of you liked this question and was able to solve this question. See, we got one problem from Lagrange's equation in 2021. Maybe you might get a question in 2023 also. 2022 they skipped. But it's not that it is not possible that you might get it in 2023. So shall we move on to next question? Are you guys ready for some more questions? Chalo. Chalo. Now solve this one. Solve this one, a beautiful problem. MSQ question. Okay, I have not written it, but it is of 2 marks. A beautiful question of 2 marks. Let's solve this one. The 50 kg crate is projected along the floor with an initial speed of 8 meters per second at t equals to 0. it's not written, but t equals to 0. Coefficient of kinetic friction is 0.4 and g is 10 meter per second square. Which one or more of the following statement is or are correct? Acceleration is constant. Time required for the crate to come to rest is 2 seconds. Distance traveled by the crate before coming to rest is 8 meter, or distance traveled by the crate before coming to rest is 10 meter. So this is the problem of kinetics, okay, and it is translation motion, pure translation motion, okay. Now acceleration of the crate is constant. We need to find the acceleration. So what we are going to do, beta? Can we apply D'Alembert's method here? Let's draw the free body diagram of the 50 kg crate. G is equal to 10. So the weight will be equals to 500 Newton, right? G equals to 10. So weight will be equals to 500 Newton. And the normal force between this and the surface is, let's say, N1, and it is projected means in x direction with a speed of 8 meter per second. So friction force 0.4 N1. Now you can see that it is moving in x direction. In y direction it is in equilibrium only. It is moving in x direction. So summation of Fy equal to 0 will give you N1 equal to 500 Newton, right? In y direction it is not moving. It is still static. But in x direction you cannot say summation of Fx equals to 0. Summation of Fx will be equal to Ma, right? And what is the net force in x direction? Minus 0.4 N1. It is moving towards the right direction. So the net force in direction of motion will be negative 0.4 N1. And the mass is 50 kg. Now N1 is 500. So what is the value of A? Minus 4 meter per second square. The value of A will be minus 4 meter per second square. Why negative sign? Because the speed will decrease, right? Due to friction, initially the speed is 8 meter per second and slowly it will decrease. So beta, acceleration is 4 meter per second square. Is it a function of time? No. Is it a function of displacement? No. Is it a function of velocity? No. It is a constant value. At all times, acceleration will remain same. So can we say that acceleration is constant? The body is moving with constant acceleration. So answer A, the statement A is absolutely correct. Acceleration of the crate is constant, right? Statement A is absolutely correct. Acceleration of the crate is constant. Second statement, time required for crate to come to rest is 2 seconds. As the acceleration of the crate is constant, I can apply this equation V equals to U plus AT. This is valid when acceleration is constant, right? So final velocity is 0, initial velocity is 8. So from here t is equal to 2 seconds. So time to come to rest will be 2 seconds. So the second statement is also correct. The required time for crate to come to rest is 2 seconds. Third statement, distance traveled before coming to rest is 8 meter. So beta, V square minus U square equals to 2as. Final velocity is 0. Initial velocity 8 meter per second. Acceleration is minus 4. So S is equals to 8 meter, right? So before coming to rest, it is going to travel a distance of 8 meters. So this statement is also correct. The last statement is wrong. It is not going to travel a distance of 10 meters. It is going to travel a distance of 8 meters only. So A, B and C, these three statements are absolutely correct. Yes? Is this clear to everyone? So this was a question of kinetics. Let's move on to next question. Are you guys ready? Everyone solved this one? We applied DLM, okay, in order to find the equation of acceleration, and we got a constant value. So acceleration is constant, and once we get acceleration, we can find time required to come to rest and distance traveled before coming to rest by simply using the equations of motion. Now let's move on to next question. Now this next question is a very conceptual problem. It is an NAT problem of 2 marks. Okay. A uniform bar of mass 8 kg and length 4 meters hangs from a frictionless hinge. It is released from rest in the horizontal position. Angular velocity when the bar makes an angle of 30 degrees with horizontal is. When the bar makes an angle of 30 degrees with horizontal, what is going to be the angular velocity that they are asking? Okay. So first we will draw the free body diagram. Now beta, let me tell you this very important thing. A lot of people make mistake here. Whenever you have this type of problem, that initially the body was like this, then the body is like this. The confusion is when we draw the free body diagram, which position should we take? Should we take the initial position or should we take the final position? In both cases, free body diagram will be different, right? So which position do you need to take? So can anyone tell me which position should you take when you are drawing the free body diagram? Right now it is at initial position theta equals to 0 degree. Finally it will be at theta equals to 30 degree. I am asking whether I should draw the free body diagram at theta equal to 0 or at theta equal to 30. Which position should I consider when I am drawing the free body diagram? When I am drawing the free body diagram, which position should I consider? Can anyone tell me? Whenever you are solving problems like this, that the body was initially like this, then it became like this, always draw the free body diagram in the intermediate position. Don't consider the initial position, don't consider the final position, consider an intermediate position between 0 and 30 degree. Why I am saying this, you will understand later. Okay, why I am saying this, you will understand later. This angle is, let's say, theta. Now let's say this is A, where it is hinged, and this is the center of gravity. So what will be the forces acting on this bar? We will have two reactions, right? One reaction in horizontal direction, one in vertical direction at the hinge. And we will also have the weight of this bar. What is the weight of the bar? 80 Newton. So we have these three forces acting on this bar. Now beta, when we apply, we can solve this problem by either D'Alembert method or by work energy method. Let's first solve this problem by work energy method. I will also tell you to solve this problem by D'Alembert's method. Okay, let's first solve this by work energy method. So in order to apply work energy method, I need to find the work done. Now there are three forces acting at 2 points, A and G. Will the point A, will the particle A move from its original position? Will the particle A displace from its original position? When it is rotating, particle A will remain here only. It is not going to move. So what is the work done by AX and AY? Work done is force into displacement. Both these forces are acting at particle A. Is the particle A going to displace? No. Displacement of A is 0. So work done by AX and AY are 0. But work done by 80 Newton is not going to be 0 because G is moving. Now this 80 Newton is acting always vertically downward. Na? 80 Newton is not going to change its direction. It is always vertical. So in order to find the work done by 80 Newton, we need vertical displacement of G. Because work done is force into displacement. Force is acting vertical, so displacement should be vertical. So let's find out the vertical displacement of G. So beta, initially the bar was like this and then it rotated. Then it rotated like this at 30 degree. Yes. This is A, which will remain at A, but this is G. This will be G dash. Now understand beta, it is not deflection of beam. In deflection of beam, we assume that deflection is very small. So if G is initially here, finally G is here. In deflection of beams, we assume very small deflection. But this is not deflection. This is motion. And it is a very large deflection. So don't consider G dash below G. G dash will be here. See, the motion will be like this. Motion will be like this. Rotational motion. So G dash will come here. So beta, what will be this vertical displacement? What will be this vertical displacement? Can anyone tell me what will be this vertical displacement of G? This angle is 30 degree and this is L by 2, which is 4 meter. L is 4 meter, na? So L by 2 means 2 meter. So this will be how much? 2 sine 30 means 1 meter. Displacement of G will be 1 meter. Displacement of G will be 1 meter, na? Array, this is 2 meter. So this will be 2 sine 30, na? Right? Hana. Yes? Okay. Now we will apply work energy method. Work done equals to change in kinetic energy. But understand this, work done will be only considered of 80 Newton and it will be 80 into displacement of G. Okay, this is displacement of G. Now, when we consider the change in kinetic energy, we have to write the equation of kinetic energy of this bar. We can either write the kinetic energy with respect to center of gravity or we can write with respect to center of rotation. If I write the equation with respect to center of gravity, I will have to consider the linear kinetic energy and rotational kinetic energy. But if I am writing the equation with respect to center of rotation, I will only consider rotational kinetic energy, half I omega square. Okay. If I am writing with respect to G, then it will be half I G omega square plus half m v square. Both kinetic energies you will have to consider. So now beta, 80 into 1 meter equals to half. Now what is the moment of inertia of a bar with respect to the end point? ml square by 3. M is 8 kg, L is 4 meter. So it will be ml square by 3 omega square minus 0. So what will be the value of omega? Are you getting 1.936 radian per second? Are you getting 1.936 radian per second? Is everyone getting 1.936 radian per second? Yes. Very good. Very good. So we have solved this problem using work energy method. You can also solve this problem using D'Alembert's method. Now understand how to solve this using D'Alembert's method. Just take moment about A. So if I take moment about A, I am going to get IA into alpha. Now the moment will be only of 80 Newton, 80 into this distance equal to IA into alpha. Now when you will take this distance, you will get L by 2 cos theta. Now here comes the very important part of the solution. A lot of people make mistake. They write theta equals to 30 degree and they consider the distance L by 2 cos 30 and then they get a constant value of alpha. What is that alpha? That alpha is the instantaneous acceleration alpha. Alpha is a function of theta. It will always change with respect to theta. So you don't have to find instantaneous acceleration. You have to find the equation of alpha in terms of theta. That is why I said that whenever you are drawing the free body diagram in such problems where there is an initial position and a final position, always draw the free body diagram in the intermediate position, not initial, not final. So you have to draw the free body diagram with respect to theta, not 30 degree. So when you will draw that, you will get alpha in terms of theta. Then how you will get omega? By integrating it. If you want, you can solve it. You will get alpha in terms of theta. Then after integration, you will get omega. Okay. Chalo. Now let's move on to the next problem. This next problem is NAT problem and it is of 2 marks. Simple problem it is. Acceleration is defined by relation A equals to minus 0.8 V, where A is in meter per second square and V is in meter per second. If at t equals to 0, velocity is 1.6 meter per second, distance traveled by the particle before coming to rest is. We need to find the distance traveled before coming to rest. We have a relation between acceleration and velocity. So we have acceleration, velocity, displacement. What is the relation between these three? Acceleration, velocity, displacement. There is a single relation between acceleration, velocity, displacement. Does anyone remember? Does anyone remember this relation? A equals to V dV by ds. Now what is the value of A? 0.8 V minus 0.8 V. So I can write this is equal to V dV by ds. Now this V and V will be cancelled. So I will get minus 0.8 ds equal to dV, right? Now how I am going to get the displacement? I will simply integrate this equation. What will be the limit of integration? This will be from 0 to s and velocity will vary from 1.6 to 0. Initial velocity is 1.6 and they are asking you to find displacement before it comes to rest. So final velocity will be 0. So this will become minus 0.8 s equals to minus 1.6. So s will be equal to 2 meters. Everyone is getting 2 meters. Everyone is getting 2 meters. Yes. Okay. So this was a simple yet a conceptual question. We have the relation between acceleration and velocity. We need to find velocity displacement before it comes to rest. So whenever you have this situation, acceleration, velocity, displacement in a single relation you need, then you use this equation, A equals to V dV by ds. Okay. Let's move on to next question, and this next question is of 1 mark. A simple question, NAT question of 1 mark. Two masses 3 kg and 6 kg are moving with equal kinetic energy. Ratio of magnitude of their momentum is 3 kg, 6 kg are moving with equal kinetic energy. Okay, and here we will take the liberty to assume that this motion is translational motion. Okay, they have not mentioned exactly how they are moving. Let's assume they are translating. Okay, so 3 kg and 6 kg are under translation. Their kinetic energies are equal. Ratio of magnitude of their momentum is. So kinetic energy of particle 1 equals to kinetic energy of particle 2. So I can write half m1 v1 square equal to half m2 v2 square. So from here v1 by v2 can be written as root over m2 by m1, and this m2 is 6 kg, m1 is 3 kg. So v1 by v2 we have got root over 6 by 3 or root over 2. Now they are asking us ratio of their momentum. So momentum means m1 v1 by m2 v2. So I can split it m1 by m2 into v1 by v2. Now what is m1 by m2? 3 by 6. And what is v1 by v2? Root 2. So this ratio m1 v1 by m2 v2 will be equals to 0.707, right? Now this was a very simple problem, 1 mark question. 0.707, right? 0.707. Very good, guys. Very good. Very good. Okay. Let's move on to the next question. And this next question is NAT question. We need to find the magnitude of force in a member CD. We need to find the magnitude of force in a member CD. Truss. So beta, in order to find the magnitude of force in member CD, we will use method of sections. How can we cut it? How can we cut it? Can we cut it like this? And then we will take moment at, let's say, H. But in order to do that, we need to first find the reaction at F. Okay. So let's find out the reaction at this support F. Consider the free body diagram of the entire truss. So we need the magnitude of this reaction RF. So we will take the moment at point A. If I take moment at point A, moment of AX and AY will be 0. I will get the magnitude of RF. What will be the value of RF? What will be the value of RF? RF multiplied by 4 meters. Yes. RF multiplied by 4 meters. This is clockwise. Then 40 kilonewton anti-clockwise. So minus 40 multiplied by 2. Then this 50 kilonewton is passing through A only, so that its moment will be 0. Then this is also anti-clockwise, 30 and 40. So this will be minus 30 multiplied by 3 minus 40 multiplied by 1.5 equal to 0. So tell me how much RF are you guys getting? How much RF are you guys getting? Are you guys getting 57.5 kilonewton? Very good, very good. 57.5 kilonewton. Now once we get RF, now we can use method of sections. Does anyone have any other idea of taking the section? Because I have this simple section. We can cut it like this. We will consider the left part. So I will get these forces, and once I take the moment at H, then the moment of this and this force will be gone. I will get the force in CD. So that's my idea. If you have any other idea, if you have any other approach, you can use that. We need force in CD only, right? Yes. Now, in order to find force in CD, I am going to take moment at H. So I will resolve this force into two components, and the moment of this vertical component will be 0. So I will have to take the moment of this only, FCD. Let's say this angle is theta. So it will be FCD cos theta. So first find out the magnitude of theta. Find out the magnitude of theta. How we can find the magnitude of theta? 1.52. Theta will be tan inverse of 1.5 by 2, right? Tan inverse of 1.5 by 2. So it is 36.87. Okay. So now I will take moment at point H. And if I take moment at point H, moment of this will be gone, moment of this will be gone, moment of this 50 kilonewton will be gone, moment of this FCD sin theta will be gone. I will get moment of FCD cos theta, which is clockwise. Then I will get moment of this 40 kilonewton anti-clockwise. And I will get moment of 57.5, this will be clockwise. So from here I will get FCD. So what is the value of FCD that you guys are getting? Minus 125 kilonewton. Now negative sign indicates that my assumption is wrong. I have assumed the force to be tensile and I am getting a negative answer, means the force must be compressive. So the answer will be 125. Magnitude of force in member CD will be 125 kilonewton. 125 kilonewton. So this was the problem from truss. I hope you guys liked this problem, because almost every year you get a problem from truss. So we solved two problems of truss today, right? So beta, these were all the problems from different topics, different chapters, and you can see that we have solved problems from all different chapters, right? We have solved problems from all different chapters, all different concepts we have covered. We have covered problems of friction. This was a problem, simple problem of friction. Then this was from statics, simple static equilibrium equation. Then kinematics of particle translation. Then kinematics of rigid bodies also we have covered. Then this was a problem of conservation of momentum. Then this was a problem from again conservation of energy. Then this was a problem from kinetics of particles, kinetics of translation. Then this was a problems of kinematics. Then this was from truss. Then this was from Lagrange's equation. We have solved problem from Lagrange's equation also. Then this was from kinetics of particles. Then kinetics of rigid body. Then again kinematics. Then again simple problems. Then truss. So we have solved problem from every chapter. I hope you guys are happy with today's lecture. And don't forget, tomorrow you have two lectures. Tomorrow you have two lectures. Okay. Tomorrow you have a lecture of mathematics and manufacturing also. At 4 p.m. At 2 p.m. you have mathematics revision through question, and at 4 p.m. you have material science and manufacturing processes part 1. So mathematics will be taken by Vishal Soni sir, brilliant, very good teacher of mathematics. And 4 p.m. Swadesh sir will take material science and manufacturing processes part 1. I don't have to introduce him. You all know that he is one of the most senior faculties of mechanical engineering for GATE and ESE, Dr. Swadesh sir. So tomorrow beta, don't forget to watch these two lectures. Okay, don't forget to watch these two lectures live at 2 p.m. and 4 p.m. And after that you have this entire schedule where we have covered each and every subject: applied thermodynamics, machine design, aptitude, industrial engineering, operations research, theory of machines and vibrations, manufacturing processes part 2, fluid mechanics and turbo machinery, strength of materials, heat transfer. Entire schedule of mechanical engineering is here with you. And you also have the name of the faculty, you have the date of the lecture, you have the times also. Usually the lectures will be from 4 p.m. to 6 p.m. But these two lectures, mathematics and aptitude, special lectures are from 2 p.m. to 4 p.m. Okay, so that everyone will be able to watch. Happy Bogi and happy Sankrantri to everyone. Happy Lodi to all my North Indian friends. Happy Pongal to all my Tamil friends. So beta, enjoy these festivals, but don't forget that the exam is very near. So don't lose your focus and don't get into the flow of these festivals. Okay. GATE PYQ series PDF is available beta. Open the PW app. Go to the GATE section. You will find crash course batch. That batch is free to enroll. In that batch, you will find the tabs of all different subjects. For example, there is a tab of strength of materials. If you go into that tab, you will find the lecture of PYQ series. You will find the PDF of PYQ series. So go to the PW app, go to GATE section and enroll in crash course. It is free. And in that, you will find the lecture and PDF of every subject. Okay. Chalo. So beta, Team Drona will always be there for you, as this is our English channel. All the teachers will be taking the lectures in this channel only in English, purely in English. Okay, we have our English channel also. If you are comfortable with Hindi, you can watch the lectures in that English channel also. GATE Wallah MEPIXC MEXCC. And if you are comfortable in English, then you can watch the lectures in this channel also. Okay, so thank you so much for being with me today. We will be meeting a lot more in the coming days, and I will bring the revision through question series for strength of materials also. Okay, so thank you so much. Bye bye, take care, all the best.